This video will focus on logarithmic functions and will answer the essential question, what are the basic characteristics of logarithmic functions? So let's start by talking about what a logarithm is. When we write a logarithmic expression like this, and the way that we pronounce that is, we would say that this is the log base b of x. Log base b of x. So the expression here has this b is the base, and that's written a little bit lower, like a subscript of the expression log x. The b is down below a little bit, but log base b of x is that expression. And what that means, what the log base b of x is this equals the exponent that if you raise the base b2 will equal x. So in other words, the base b in the logarithm is similar to the base b of an exponential expression, and the answer to the log base b of x is the exponent. So one of the main things to remember is that logarithms are exponents. As you try to familiarize yourself with logarithms, the best thing is going to be to keep going back to this idea that logarithms are exponents, because we're more familiar with exponents. Logarithms, what we'll see in a little while in a future video, is that logarithms are the inverse operation to exponentials. They undo exponentials. And so, in a sense, logarithms are the exact same thing as exponents, and we can rewrite logarithms as exponents to help us understand what they are. So, for example, here are some examples. Looking at a few of these will help us understand a little bit better the ins and outs of logarithms. Let's start with log base 3 of 243. So log base 3 of 243. What does this equal? Well, the best way to approach this at first is to understand this as an exponential expression. The base is 3. The base of the logarithm is going to be the base of the exponential expression that we write, and what we're looking for is an unknown exponent that we could possibly raise 3 to in order to equal 243. Now that's an expression we have a better chance of figuring out than understanding what a logarithm is, as we're just starting to learn logarithms. So what exponent is it on 3 that's going to equal 243? The answer is the fifth power of 3 equals 243. And so the log base 3 of 243 is 5. The answer of the logarithm is the exponent. And that's what a logarithm is. It's the missing exponent. It's the unknown exponent. Let's try log base 2 of 16. What does the log base 2 of 16 equal? In terms of exponents, remember, we're looking for the base 2 raised to some unknown exponent is going to equal 16. That one you can probably figure out in your head. 2 to the 4th power is equal to 16. So that 4, this exponent, is the answer to the logarithm. The logarithm is the missing exponent. Let's try a slightly more complicated one. How about the log base 5 of the square root of 5? What does that equal? Let's convert that into an exponential expression. So the base is 5. We're missing an exponent, and the whole thing will equal the square root of 5. This is testing your ability to convert between radicals and exponents, but hopefully it should be no problem to recognize the square root of 5 as 5 to the 1/2 power. Well, in this way, the missing exponent is actually, this missing exponent is actually right here because the bases are the same. 5 and 5 are the same. So the missing exponent is 1/2. 5 to the 1/2 power is the square root of 5. So log base 5 of the square root of 5 equals 1/2. How about log base 8 of 1/64th? So converting to exponential notation, this means there's an exponent on the 8 that's going to get us 1/64th. Well, notice 1/64th is really 1 over 8 squared, with that 2, that exponent of 2 being in the denominator. So the unknown exponent, 8 raised to an unknown exponent, is really, and we can rewrite 1 over 8 squared as 8 to the -2nd power. And there we've just figured out our missing exponent. This unknown exponent equals -2. So back to the logarithm, log base 8 of 1/64th equals -2. Okay, 2 more simple examples. How about log base 6 of 1? Take a minute to think about what that means. That means 6 to an unknown power, and the answer equals 1. So what power of 6 equals 1? There's only one exponent that you could raise 6 to in order to equal 1, and that exponent is 0. 6 to the 0 power is 1. You might notice that that actually isn't dependent upon the base 6. That would be true of any base, regardless of it being 6. How about the log base 4 of 4? What does that equal? What if the base is the same as what we're taking the logarithm of? That means we're missing an exponent on 4 that would equal 4. And it's easy to see 4 to the 1st power equals 4, so that answer is 1. And you say that you might notice that that's not dependent upon 4 either. That could be any base, log of any base, as long as we're taking the logarithm of the same thing of the base. And that leads us to our properties of logarithms. These first 2 basic properties we just saw illustrated in those previous examples. If you have log base b of 1, the answer is always going to be 0, because 0 is the exponent for base b that will equal 1. And likewise, if you're taking the logarithm that's a base b and you're taking the logarithm of b, where the base and what you're taking the logarithm of match, then that answer is always going to be 1. Because the first power of base b equals b. Now this third basic property here, if we look at this and we ask ourselves, what is this asking? We're taking the log base b of b to the y power. If we think of that in terms of exponents, we want the base b raised to an unknown power to end up equaling b to the y power. Well, since the bases match, this unknown exponent is this written out exponent. So the answer here is y. And this basic property tells us if we're taking the logarithm of an exponential expression here, where the base is the same as the logarithm's base, the answer is always the exponent. And we see that actually take place here if we think about this as b raised to the 1st power. The bases match, and the answer is the exponent. And this last example, this last basic property here, if we look at what this is asking, the formatting is a little confusing, but let me rewrite it. So this is actually the base b raised to the logarithm base b of x power. That logarithm is the entire exponent of a base b. You can see It's a little bit confusing there. But what is this asking? This is asking us to figure out what is b to an unknown exponent. Well, this unknown exponent is an unknown exponent. Let's see if I can rewrite. If we try to rewrite that, that's asking us to write out an unknown power of b equals x. An unknown power of b equals x. Well, this what I have in blue, this blue expression, is what this right here is saying. What is this unknown power of b? And the purple expression tells us the unknown power of b right here is x. And so that tells us that this answer is x, which tells us the answer to the property is x. And again, what we see is if we have a base b raised to an exponent that also has a base b, so in other words, this base and this base are the same exact base, then the answer is going to be the x. And that's the basic properties of logarithms. The last thing to note are common logarithms. Common logarithms have a base of 10. 10 is such a common base that it's called the common logarithm. And instead of writing log base 10 of x, let's say, we don't write it that way. Very rarely will you ever see log base 10 of x. Instead, because it's a common occurrence, instead it's written just as the log of x. And so if no base on your logarithm is written, the assumed base is 10. And this is a common logarithm.